A projectile fired at 30 degrees to the ground is observed to be at same height at time 3 seconds and 5 seconds after projection during its flight. The speed of projection of the projectile is. Okay. See, this is what I was mentioning a couple of seconds back. This is a really good question. Unlike the first 7 questions, which were very basic for a JEE mains, this actually is relevant with respect to the. I would say this serves purpose to the to the JEE mains exam. So let us first try to understand the concept here. Okay, so I'm deviating from the 2-minute target. Why, I'll tell you. So say this is the ground. Okay, and an object is projected with velocity v at an angle theta. Now we know that the path of the object would be, the trajectory would be what? Would be parabolic in nature. Let us assume that it is at these two heights that the object is at the same height from the ground, and let us name that height as h. Okay, height as h. All right. Now what we'll do is we will try to, okay, so it is given that this is the same height at 3 seconds and 5 seconds. So for the time being, I'll consider this much time to be t1 seconds. Okay, and to reach this position, so say from A and B is same position, so time to reach B is t2. Okay, so time to reach A is t1 and time to reach B is t2, and height at A is h, height at B is also equal to h, right? So this is what we have. Now let us find out what is height at A. See, what is the equation for height at A? Height at A is actually the vertical displacement, right? Height at A is actually the vertical displacement, where vertical displacement at position A. Now what is the formula for vertical displacement? Let us write down that first. So we have S is equal to ut plus half at square, right? Now for the vertical motion, what is S is equal to? S is equal to Sy, displacement in the vertical direction. U is equal to U sine theta, and A is equal to minus G. So if we substitute these values here, what do we get? S is equal to Sy is equal to U sine theta into T plus half into minus G into T square. Now what is the actual value of Sy here? Sy is the vertical displacement, right? So this is the vertical displacement. What we have here is the vertical displacement, and that value is given to be h, which means I can write here h is equal to, right? H is equal to U sine theta into T, plus minus G by 2 into T square. Now let me try to rearrange this equation in the form of a proper quadratic one, which would look something like this. Which would look G by 2 into, right, G by 2 into T square minus U sine theta into T plus H is equal to 0. Okay, why did I write it like this way? Because we know if the equation, if the roots of the quadratic equations of the form ax square plus bx plus c is equal to 0 in terms of x, if the equation is here is in terms of x, and if the equation is in terms of x, then we know that if alpha and beta are the roots of the equation, if alpha and beta are the root of the equation, then what is alpha plus beta is equal to? Alpha plus beta is equal to minus b by a, right? Now this is very basics of class 11th quadratic equation, right? Class 11th quadratic equations. Let us make use of that application here. So this equation given to us is in terms of t, and instead of alpha and beta, let us assume that the roots of the equations are t1 and t2, In which case, what would be alpha plus beta? Alpha plus beta would be t1 plus t2, which here would be equal to minus b by a. Let us now find out what is minus b. So have a look here. G by 2 is a, right? So we have t corresponding x here. So what is b? B is u sine theta. Therefore, we can write here that t1 plus t2 is equal to minus, what is the value of b? B here is minus u sine theta, right? So let's write down here. So a is equal to g by 2, and what is b is equal to? B is equal to minus u sine theta. So applying these two in the equation, minus b by a becomes minus of minus u sine theta by a is g by 2. So this will give you 2u sine theta by g, which actually is equal to the time of flight. Therefore, we can say that t1 plus t2 is actually equal to the whole time t, right? T1 plus t2 is equal to whole time t. Now, if t1 plus t2 is equal to whole time t, from the given equation here, what do we have? T1 is given to us as 3 seconds, right? T1 is given to us 3 seconds and T2 is given to us as 5 seconds, which means T1 plus T2 is 3 plus 5 is equal to time of flight, which is given by the formula 2u sine theta the whole upon g, which implies 8 is equal to, or say 8 into 10 by 2 is equal to u into sine theta. Theta is given to be 30 degrees, so this is sine 30. Therefore, 5 into 8 is equal to u into what is sine 30? Sine 30 is 1 by 2, so 5 it's a 40, and therefore u is equal to 40 into 2, which is 80 meter per second, which gives us the correct option as, oh, it's some numerical question, so this is 80 meter per second. Now, there is another way of looking at the question, which actually would be very simple, which goes like this. So, this much is 3 seconds, right? And, I'm sorry, my bad. So, this much is 3 seconds, t1. And then from here, we have total is 5 seconds, which means from 3 to 5, somewhere below, between this is 4, which means the maximum time for, the time to reach the maximum height is 4 seconds. Or in other words, the time of ascent is 4 seconds, and therefore time of descent will also be equal to 4 seconds, and therefore the total time of flight will be equal to 8 seconds, which will be equal to 2u sine theta upon g. Yes, you can proceed in this way as well. But then what you miss is this whole conceptual integration of quadratic equation into this projectile motion. That's a takeaway from this question. Anyway, having said so, let's move on to the next question, which is again based on components of velocity. Okay,